10 million lashes, but I no cry. 10 years burial, but I no die. Take what's rightfully mine. Take what's rightfully mine. But that aside.
Welcome to my Sword Academy. So today we are going to be looking at question on traveling waves. And this question, we are going to see a progressive wave with an equation, and we want to find the amplitude, the frequency, the wavelength, the speed, and the phase angle from a particular distance. So here we have the equation of the progressive wave as 0.2 sine 100 pi t minus 10 pi x all over 17, and is given in meters. So how can we be able to calculate for these different parameters: amplitude, frequency, wavelength, speed, and so on? So before we solve this, we have an equation that represents a traveling wave. So the general equation for the traveling wave is given as a sine 2 pi ft minus 2 pi x all over lambda. So this gives us the general equation for a traveling wave. Now, for this progressive wave, we have the first equation here. So I'll call this one equation 1 and call this one equation 2. So we are going to compare equation 1 and equation 2 and see what they have for us. So we have equation 1 is y equal to 0 point this, and equation 2 is also y equal to this. So when you compare and evaluate it, you are going to see that after the equal sign, we have 0.2 before the sign function, and then here after the equal sign we have a before the sign function. So that means that 0.2 is equivalent to your a. So that means a is equal to 0.1.2. Since this is given in meters, the answer should also be in meters. So where a is the amplitude, so we have gotten the amplitude. So amplitude is a equal to 0.2 meters. Now the frequency, to get the frequency, we have to look inside the sine function. So we have the sine function have 100 pi t in the question, and here we have 2 pi ft. So if you compare with these two, you can see that 2 pi ft is equal to 100 pi t. So the t here is what we are using as a yardstick to do that comparison. So the same way we are going to do when we compare between these two, we are going to use the x as the yardstick for the word comparison. So now 2 pi ft should be equal to 100 pi t, because both of them are ending with t. So t, we cancel out t. Now we can also see there's a pi here and there's also a pi here. So what we have left is 2f equal to 100. So if I divide through by 2, I divide through by 2, that means that my f is equal to 100 divided by 2, which is 50 hertz. So the frequency is equal to 50 hertz. So we have gotten the frequency as 50 hertz. Now we also compare with this. Remember, we say x is the yardstick for the comparison. So these two have the x, so we compare it. So that means we are going to be having from the comparison that 10 pi x all over 17 is equal to 2 pi x all over lambda. So you can see that x, we cancel out x, pi, we cancel out pi. So we have this left. So we can cross multiply. So that 10 will multiply with lambda, which is 10 times lambda, which is equal to 2. We multiply with 17. So we have 2 times 17. So I'm looking for the wavelength. I'll divide through by 10. I divide through by 10. So 10 we cancel out, 10 we cancel out. 2 times 17 will give us 34. So 34 divided by 10, we have that lambda is equal to 3.4 meters. So the wavelength is calculated as 3.4 meters. Now we have gotten the wavelength. The next question says its speed. So let's find the speed. So let's get the speed from here. The speed v is equal to f lambda. So that is the formula for calculating the speed of a wave. So frequency times the wavelength will give us the wave speed. So that means the wave speed is the frequency is 50 times the wavelength is 3.4. So if we should multiply this, we are going to have, this will give us 170 meter per second. So that is the speed of the wave. Then the next question is on the phase angle at 34 centimeters from the origin. So I will leave number 5 for you to solve it.